What is up, great people? Welcome once again to another video with Nosana. In this video I'm going to be proving a trig identity that one of the learners in metric sent me. You guys should just keep those videos rolling, and I will just keep the content coming so you guys can keep scrolling. Alright, if you're watching these videos from Nosana and it's not your first time yet, you haven't liked, you haven't subscribed, you haven't shared, you're not being nice. Help the community grow. Maybe it is your neighbor that needs help, your neighbor's son that needs these lessons. They're highly affordable. We can't rob you the chance of becoming that doctor, that engineer, that that scientist or accountant that you want to be. We can't rob you of your future. So I've got lessons that are highly affordable, and I offer online or one-on-one tuitions. So this the content is good, and I bet you'd be tempted to gatekeep, but we don't do that. Just imagine if you're in the shoes of that person who is going to discover this from you. Alright, so cool, enough talking for now. Let us jump into this. Trig is overwhelming, right? Like, there's a lot that is going on, and some light can be very, very helpful. So that's what I'm here to bring. And this is a question that they've requested that I do. 6.1.2. That's the question that I am going to be doing. So yeah, so without wasting much time, let me rewrite this question here where we can all see it. We have cos, right? We have cos 90 degrees minus x, right? And yeah, it looks like it's a long question, but it is not an issue. The longer the question is, the better, right? So that we actually get an overall understanding of what we are working with. So I'm rewriting this. Let me just share some tips with you guys. Some free tips. Right now, what we notice is that this one here is a combination of reduction, right? There's reduction, there are double angles, there's reduction and compound angles from what I can see, right? So no need to panic when you see this. You can look at the mark, and at the marks there you can see that it's 6 marks. That seems like it's a lot, right? It is a lot. Okay, so don't panic, right? What you can just do is grab your pencil as soon as you see this question, work with what you know. I trust that for you to enter that exam, you would have practiced a lot, right? You've done a lot of practice. So yeah, you can't just walk in that exam without practice, unless you are Albert Einstein, right, or some genius, which I am pretty sure you are. But let us not take chances. Okay, cool. I trust that you understand that. So now let's do it. Let's do this. Right, it's not as heavy as it looks, right? Okay, so we know the reduction methods and what. So let us simplify it first. So the first step is to simplify. When we have a question such as this one, our first thing to do, or what I'm going to do first, is simplify. We have cos there. Okay, okay, let me just do this. Sorry about that. Let me see if I can draw the Cartesian plane like that. Okay, just trying. Okay, so we have that as our Cartesian plane. Okay, so now we're just going to mark that. This is our what? This is our y. This is going to be our x, right? So we know what's happening here. We have 90 minus theta, right? See there, we have 90 minus x. In this case, we have 90 minus x, right? 90 minus x, and then here we have what? We have 180. You know what? So let me not put that. Let me just put theta, right? Because we know that that's what we've been working with since. So right, oh my gosh, God, me. Right, so minus theta there. Right, in here we have 180 minus theta. Here we have what? 180 plus theta. Here we have 360 minus theta. So that is what we have, ladies and gentlemen. So what we need to do is reduct this, right? And we know that here we have 90 plus theta. Okay, cool. So what we have here, we have cos 90 minus x. So what we know is that when we have minus it is in this quadrant here, 90 minus, and everything is positive, so we're just going to change. It's called a co-function, right? Okay, so here we're going to have what? We're going to have positive sine. Remember, we are simplifying it now. We're going to have sine x, positive sine x, right, times this becomes cos y, right? Now we have not, check here. Okay, let me write that in red. This part here, let me take it there, right? This part here is sine, right, minus y. So what we are taught is that when we have minus y there, we can, when we have a negative angle, we can just add 360. Why? Because 360 is just one revolution, so it doesn't make a difference. It's like starting from where you, it's like stopping from where you started, so it doesn't make a difference. So that's what we are going to do there. We are going to add 360 in there, so it will be 360, sorry, it will be 360, it will be 360 minus theta, sorry, not minus theta, it will be 360 minus y, it will be 360 minus y, right? It will be 360 minus y, and this is where 360 is. It is in the fourth quadrant. So if 360 is in the fourth quadrant, what does that say? If 360 is okay, and we are okay, so we're saying sine 3, only cos is positive in here, right? Only cos is positive. Why? Because all students take cake or coffee or Coca-Cola, right? So now what we're going to do is we see that this is the quadrant that we have sine 360 minus y. We're going to change that, right? We're going to write plus, right? Usually it's supposed to be plus, but now we have it in the fourth quadrant, so it becomes negative, so it will be minus sine y, right? But then we are multiplying it, and here we're multiplying it with cos 180 plus x. See here, cos 180 plus x is in this quadrant, sine. Only sine should be positive in there, but now cos 180, I mean only sine is only positive in here where it is 180 minus an angle. But now here we have 180 plus an angle, and only 10 is positive. So what we do is we say minus, right, minus cos x, right, minus cos x. But what do we see? We see that we are multiplying, right? We're multiplying this sine y and cos y, right? So this sine here can become this, and this will multiply, and this sine here becomes a positive. Okay, that becomes a positive. All right, so this becomes a positive. That means that I need to erase this. That means that I need to erase this and write it properly now, and say what? And say cos x. Isn't that right? And say cos x. Okay, cool. So now we move on to the new denominator. So the numerator has been dealt with. Now we are going to deal with the denominator. What do we see there? We have cos, so we're just going to rewrite that. We're just going to say cos x, right, times what we have there. We have cos 360 plus y. We don't have that. Also in this bracket here, we actually have cos 360 plus y. In other words, we just have y. We just have an angle in there. Okay, so remember, everything is positive in there. So what are we going to do? What we are going to do is we're just going to say cos y. We'll say cos y, like that. Okay, because the 360 is not making any difference, right? And remember, everything is positive in the first quadrant, right? So now we're just going to write the plus sign, and now we have sine 360 minus what? Sine 360 minus x, and this is the quadrant where we have minus 360. Cos is positive, where we're saying 360 minus an angle, so this becomes negative. This becomes negative. Okay, let me just put a bracket. This becomes negative sine, becomes negative sine x, right? But I am multiplying it with what? I'm multiplying it with y. You see that I am multiplying it with y. So now when I'm multiplying, that means this negative has to be a positive. So allow me to just rewrite this now. Allow me to just rewrite this. I gotta erase this first. Okay, let me just erase this positive sign. It is, we are moving it to become a negative, so it will be minus, but it will be minus sine x times y. All right, okay, cool. So we are actually done. Okay, not that. Here I'm supposed to write sine y, right? Sine y. Okay, so by the way, I forgot to indicate that this is our what? This is our left hand side, LHS, right? And then this is our right hand side. This is our right hand side. This is our RHS. Okay, cool. So let us proceed. Now we have this remaining. Okay. Now we have this. Now we have this. We can just see that we have a bunch of compound angles here. What we have here is a compound angle for sine. Remember, when you have sine, the next step will be what? Will be sine, right? Sine x. And when it's sine, it means you're just gonna add the angles like that. Hey, okay, you're just gonna add the angles. Oh my days. So that means you're just gonna add the angles, and now that's the top part. Now you're gonna do the bottom part. You have cos x, cos y, sine x, sine y. What does that mean? That means cos, right, is the compound angle for cos, and you have x. And remember that when the sign is negative outside here, if the sign is negative, that means the sign has to be positive in there, right? It has to be positive. So, right, this is actually just the same as saying, literally, it's just the same as saying what? This here is the same as saying, it's almost the same as saying sine theta over cos theta, right? Because this would be equal to what? This would be equal to tan theta, but we're not there. I'm just showing you guys what it is equal to, right? So we know the tan ratio. Moving back to the tan ratio, what we'll pick up is that this is actually just going to be equal to what? This is actually going to be equal to 10, right? Okay, sorry. This is actually going to be equal to 10x plus y. Okay, like that. And this was our right hand side, ladies and gentlemen. It's an easy one. And this is our left hand side. So you didn't have to do much with the other side. Okay, you didn't have to do anything to touch the left hand side, to touch the right hand side. All you just had to do was to work with the left hand side. Okay, so thank you guys for watching. Please comment, share, and subscribe from wherever it is that you're watching from. Instagram, YouTube, TikTok, right? Just keep the link moving and help the community grow, right? Till we meet again in the next video. Bye.